Hi, everyone.
Hello.
Hey, hold on one second.
Hi.
Hey, where are you guys? There you are. All right. We're just gonna wait like 5 minutes to let everyone. I'm not gonna do this all the time, but it's the first week, so I'm gonna give people 5 minutes to get here. So just chill out for a little bit. I'm gonna stop recording now. Okay. Anyway, the pre-assessments, my vision is that the pre-assessment is the very, 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 very first thing that you do before you do anything else study wise for that chapter. So it's a pre-assessment, right? So I give you unlimited trials, so you're gonna get all the points if you do them. You know what I mean? Eventually you'll get all the points, but the point is to figure out the first time you take it, how much do you actually know? Did you get them all wrong? That's not good, but that's okay, because that means that you just need to learn all those things before you actually get to the quiz, the chapter quiz. So yes, to answer your question, it is the thing that I want you to do first, or should do first. You don't have to. You just have to get them done. They're due the same thing, the same day and time that everything else is due, like the quizzes and the whatever. Yeah, the quizzes. But I would like for you to do them first before anything else, just to gauge how much you know about the content in that chapter. Does that make sense?
Yes, it does.
Okay, awesome. So I do have some announcements today before we start, but today's our first actual class. Yay! Am I recording? Yes, I am. Okay, so first of all, I just want to make it clear, right? The quick tutorial, the sig figs quick tutorial, if you didn't do it before our class today, like right now, too bad, so sad. That means that you do not get the bonus points. So that's why I tell you, that's why I announced it, that's why I told you in class, tomorrow we're doing sig figs, you got to do the sig figs quick tutorial, because if you don't do it before we come to class, that quick tutorial, you will not get the bonus points. You're more than welcome to watch the video over and over and over again. That doesn't matter to me, but you will not get the bonus points. And I really would love for you guys to pay attention to that, because I'm not going to have any sympathy for anybody if I tell you things 7,000 times, right? You see how many announcements I send you guys. So I tell you all these things so that there's no excuse, right? So there's several people that did not do the quick tutorial. So right there, you've lost 3 bonus points, 3 possible bonus points. So I don't have any sympathy for that. Another thing is that a bunch of you did not do the pretest, the whole 30 question at the beginning of the class. And if you're still here at the end of the class, you take the same thing. And if you take both of them, you'll get bonus points. A bunch of you didn't do that. That was due yesterday at 10 o'clock. You had any time between 2 and 10 o'clock yesterday to do that. And you can't take it now. That's it. It's too late. So now you've already lost those bonus points. And if you do not, that I sent out a Google form, and I do not have everybody's responses yet. So this is just so you understand that if I tell you to do something, you have to do it. If you do not do it, I do not have any sympathy for you. There's no way you're going to get any points. You don't give me a sob story. All right? Because you are all adults and I gave you enough information and enough time to do it, and lots of reminders. So I just want to kind of warn you for the future, right? If I'm telling you to do something, you got to do it by that time. There's no extensions. That's it. Because you're putting more work on me. There's 45 of you and only one of me. So you can't expect me to be altering things and doing things just because you forgot something. No, sorry. So to reiterate, that Google form, I need it done by today if you haven't done it. There's still like 10 of you that haven't responded. You understand that if you do not respond, I am going to put you in whatever group I want. And actually, it's probably going to be all the people that didn't respond, I'm going to put those people together. And they're obviously the people that don't care about the class. So don't do that, right? Get yourself, it's a quick survey, get it done, and that's it. And another thing about the test that I told you, RLB or Proctor U, everybody has not responded to that either. You need to tell me today. and you need to take that fake test. If you decide you want to do RLB, you got to take the fake test so that you can make sure that it actually works. All right, so if you do not tell me what you want by today, Proctor U or RLB, I'm going to tell you how you're going to take the exam, and you cannot complain. All right, so I'm just want to make sure that all of that is clear so you guys understand that. So now mean tournée gone, and now I want to start class. So since I said all that stuff, do you guys actually have any questions or anything you're concerned about of all those things that I said?
I have a quick question, but it's not related to what you said.
Okay, what's up?
It's about the bonus points that we get for the quick tutorials.
Yep.
I forgot, like, do we get bonus points only if we get all of them right, or do we get partial points if we get some
You
of them?
get partial. You get partial. So whichever question you got right, you'll get points for. You don't have to get all of them right. Yeah. Most of you got them for the sig figs one, the ones that people that did it, most of you got them all right. I think maybe one or two people got 2 right instead of 3 right. But that's okay. It's still bonus, right? So yeah, you don't have to get all of them right. Any other questions?
I have a question.
What's up?
So is there going to be like an announcement when you like grade all of those?
Yeah, it's already, your grades are already on your grade book. Just look for it.
Okay.
Yeah.
Okay.
I'm not going to announce it because again, Kezia, you love putting work on me, don't you? No, I don't want to do any more work than I already do. I do so much. So yeah, just you'll see them posted. Typically, I mean, I start getting lazy, but I try to do them as quickly as possible, specifically before we talk about the topic. You should already, like, I know I graded you guys and I put everybody's grade for the sig figs quick tutorial already. So it should be on your grade book. And if you don't see something or you see something wrong or you don't understand, email me, let me know, okay? Any other questions?
I have one.
That's it?
No, I have a question.
Okay, yes, ma'am.
Just for clarification, the proctor U is where you have a proctor watching you, and then the RLB is like you're doing it by yourself.
Yeah, you're doing it by yourself, but your computer is actually recording you. So really, what it does is like it flags you if there's something that that you're not supposed to be doing. It sends a flag, and then those flags are all like recorded, and I get to see all of that.
Okay.
Yes.
And how long do we have to take the RLB fake test?
I'm sorry, I couldn't hear that. Say it again.
How long do we have to take the RLB fake test?
I would do it like it's not even a test. It's just one question. It's like a silly question that I ask you. So it's not going to take you more than 5 minutes to complete it. But I would take that as soon as possible because we've got to figure out if RLB actually works and it works perfectly for you with your computer. Because if not, then you got to do it by Proctor U, and you need to sign up for Proctor U like soon. Like they don't, you know what I mean? So like I would love for you to do it as soon as possible.
Okay.
All right. Any other questions? If not, we got to get started. All right, cool. So, all right, guys, today I am going to lecture, boring, but I'm going to lecture about sig figs. So most of you, a lot of you did watch the quick tutorial, and I hope you did other things too. I hope you've started to read. I hope you maybe watched other videos on YouTube. Khan Academy is very good. So you need to have done, hopefully you did a bunch of stuff. So this will be super easy for all of us. So let me take that out. Let me share my screen. And remember, I'm not gonna be able to see you because I'm gonna minimize all of you guys. So if you have a question, talk, okay? Like that goes specifically for Justin. Justin, you gotta talk because I can't hear you, man. Or I can't see you if you raise your hand. So, okay, this is a lot of words. We're not gonna read all this, but I actually use this for the quick tutorial, so you might notice it, you might recognize it. One of the big things about, and by the way, guys, you can stop me at any time. You don't have to wait till I'm done talking. I love interaction and questions, okay? So anyway, the quick tutorial sort of went over how to decide how many significant figures are in a number, right? That's the main thing. Those are the rules on how to decide how many sig figs you have. But one of the big things I like to talk about in this class is usually a student may know the rules, but may not know how to apply them when you're actually in a lab and using an instrument. The whole point of significant figures is that the sig figs are determined by the instrument that you use. And that instrument may be a ruler, maybe my mass spec, my instrument. It may be a balance, it may be whatever, but that's what limits the number of significant figures. So not only do you have to be able to, if I give you a number, be able to say, oh, that has XYZ sig figs, but you have to be able to use instruments and know how many sig figs to report with the instrument that you're using. Does that make sense? Hello, hello, hello.
Yes.
Okay.
Yes.
Thank you, thank you, thank you. I love engagement. Thank you, guys. All right, so let's do an example so you understand what I mean. So you guys see this ruler, right? All right, you see that blue line? I want you guys to just blurt out where you think that blue line is. Tell me where that blue line is.
6.3.
Okay, 6.3. Anybody else? How about something different? Anybody else? Not everyone thinks that's 6.3. Come on.
6.25.
6.25. Loving it. How about something else? I want 4 different answers. Give me something else.
6.17.
6.17. Look at this. How about one more?
6.35.
6.35. How about, would you guys be okay with like anybody else? Anybody else want to say one or no?
I say 6.4.
6.4. Okay. I'm gonna say, just for the purpose of adding something, I'm gonna say 6.2999. How about that? Cool. All right.
Yeah.
So if first of all of those answers some of them are correct, and correct because you guessed correctly, and some of them are wrong. So for example, the person who said 6.25, the person who said 6.17, the person that said 6.35, the person, which was me, that said 6.29999, that is also very uber wrong. Does anybody know why? So basically the only people that actually did it correctly was 6.3 and 6.4. Can anybody tell me why everybody else that said the other answers were wrong? Does anybody know why?
Because it communicated that the instrument had a degree of precision that it actually did not have.
That's exactly right. So in layman's terms, that was Justin, right? Was that Justin? I think I recognize Justin's voice now. So for example, I had given you the example of 6.2999. There is no way with this instrument, with this ruler, that I can guess that blue line is at 6.299. I only know for certain that there's a 6 and that there's a 7. So I can only guesstimate one digit after what I definitely know. So 6.3, yep, that could work, or 6.4. It just depends on the reader. That there's always a degree of uncertainty with the reader, with the person who's actually reading the number. But you cannot say 6.35 because there are no little divisions here. If there were little divisions between the 6 and the 7, then you can say 6.3 because I know it's for certain at 6.3, but then I guesstimate the digit after. Does that make sense?
Yes.
Yes.
Okay, so you have to make sure that it makes sense, because typically if we would be face-to-face, you would be going to lab, right? And you would actually be going to a face-to-face lab. And I can tell you that, yeah, it makes sense and I'm talking about it on the screen, but then you go to a lab and you measure things and it's like you forget the rules, right? So think about it. If you're using a beaker, a graduated cylinder, pipette, all of these things have different graduations, have different amounts of precision. Hello? have different amounts of precision. So when you're using that, let's say you're filling up a beaker and you fill it up to a certain line, the beaker is the least precise thing that we have in our lab. So you can't say, oh, there's how much water is in there? There's 35.625 liters of water or milliliters of water. That doesn't even make sense. There's no way. They're not that precise. So you have to only report the amount of digits that you actually can from the instrument that you're using. And that's really, really important that you understand that. I actually gave a question in an exam. I don't know, I've done it probably a couple of times, but I gave a picture of a graduated cylinder. And I, made like a water line. And I said, okay, guys, tell me how much water is in this graduated cylinder. And I got stuff like this. I got stuff like 6.2999999, which there's no way that they could have known that. So they don't understand how to apply significant figures when they're using instrumentation. So make sure you remember that. Have you guys, and the reason I have the balance, if we're moving on to the balance, you've noticed that, some balances are really good, some balances are really bad. This one that I'm showing here is not that good. It's only got 2 decimals, but regardless of the balance that you have you ever noticed that what happens, like when you see a balance and you weigh something, does anybody know what happens to the last digit? What is the last digit of the balance? When you put something on there, what's going on with the last digit that you see on the screen? Does anybody know?
Does it round up?
It does round up, but it also rounds down. Like if you've noticed, it goes up and down, like it fluctuates, because that's what the balance, until it sets on something. And that's what the balance is trying to do. The balance is trying to do what you did with the ruler. Is it 6.3? Is it 6.4? It's going back and forth until it sets on something. If it's a good balance, it'll set. If it's not a good balance, it'll keep going up and down, because that's what it's doing. It's trying to guesstimate the last digit that it can with its particular precision that it has. Does that make sense? Everybody good with that?
Yes.
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 Okay. Wow, you guys sound like you're not happy. Okay. All right. So moving on. I did go over this in the video, so you should know these rules. There's 4 rules. They're pretty simple. Your book has them as 5 rules. I put them down into 4 rules. But they all are really pretty simple. And hopefully we can do this really quickly. The first rule is, all non-zeros it's sort of like a dum-dum rule, but all non-zeros are significant. So for example, all of these numbers here they don't have a 0, so they're non-zero numbers. So can anyone tell me, and you can write on my board if you want to, if you guys want to actually write on the screen, you can go ahead when I ask you a question. How many sig figs are in this last number here, this 1999?
Four.
Okay, how many are in, good job, the 4 with the blue 4. How many sig figs are in, let's say, that number? That's a dot, by the way, that's a decimal place, 65.053. That's 5. How do you know, why is that 0 in the center? Actually, why did you count that one? Whoever's writing, you can speak.
Zeros trapped between non-zero digits are significant.
That's right. And it sort of makes sense. How can you say, for example, okay, yeah, this guy's significant, this guy's significant, this guy is.
Because it's in between the numbers.
Yes, that's exactly right. And like I was saying, how can you say this is significant, this 5, and then this 5, and then this 3 is, but this guy isn't? That doesn't even make any sense, right? So that's the second rule that I want to talk about, the number 3. Zeros trapped between non-zero digits are always significant. Then that makes sense. So how many sig figs are in this number here? 0.0302. How many?
3.
That's correct. Does everybody get that? Everyone's good with that?
Yes.
Okay. So
Yes.
the other 2 rules are, if you notice, there's 4 rules and 3 of them have to do with 0. Zero is the one thing that gives people anxiety. I don't know why. They don't know how to deal with the zeros. So we've already taken care of one zero rule. The other zero rule, the third one that third rule we're going to talk about is this one, number 2, leading zeros. Leading zeros never, ever, 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 ever count. Does anybody know why?
They're placeholders for the significant numbers.
That is correct. They're not doing anything besides, let me erase this. They're not doing anything besides holding the place for the first non-zero number, which is that 5 in that example. So that example right there, the 0.0054, how many digits, how many significant digits does that number have?
2.
That's right. That's right. And I hope that makes sense to everyone. You're not, the zeros before never, ever, ever, ever count. If there's no non-zero digit, like if all you see are zeros and then there's the first non-zero digit, that's where you start counting. But instead, if I had this number, instead it would be 10.0054. Now that's different because now you're going to the other rule. These zeros are sandwiched in between two non-zero numbers, which would be the 1 and the 5. But I hope you guys get that. So we're on to the 4th rule, which is also easy, but this is the one that gives people the most problems. So trailing zeros. Trailing zeros only count if you see a decimal point in the number. It is very important you understand that, okay? So for example, look at the examples I have there, and let's not talk about this example right now, but look at the examples I have. 700. How many significant digits are in that number right there?
1.
Why 1? Why 1?
There's no decimal present.
Who is the only, in what place is the only significant digit there? Can you tell me that?
Wait, I didn't understand.
Say it again.
In what place? Is it the ones place, the tens place, the hundredths?
Oh, the hundredth.
Okay, so it's in the hundredths place. So the only significant digit in that number, it's in the hundredths place, right? So that means if I reported this answer, and I did this in the quick tutorial, but if I reported this answer, this is my answer for my data, it's 700 with no point. That means that what I'm telling the reader, that my answer could be anywhere between 600 or 800, right? So I'm creating a range because I'm telling them the only significant digit that I know of is all the way in the hundredths place. It's not a very good number. But now if I switch over and I say, oh, no, wait, that is my number. That is my data point. How many sig figs do I have now?
3.
3.
What's the last, what place is my last significant digit?
The ones.
The ones place, which if you report that number, that means that your range is 699 to 701. This is obviously a better range. It's a smaller range besides this one that's a lot bigger. So that's what you're doing with significant digits. You are adding accuracy to your number, precision to your number. So it's very, very important you understand that. If I gave you something like, let's say, I don't know. How many sig figs does that number have?
5.
1, 2, 3, 4, 5. That does
Wait,
not
1,
have 5.
2,
That's
3,
incorrect.
6.
6.
Okay, so the person who said 5, because I can't see you guys talking, the person who said 5, do you understand why it's not 5?
No.
Okay, so what is the rules, the zeros after rule that we just talked about? What is
If they're trailing a decimal point, then they count.
okay, so say that again. Say that again one more time.
Okay.
Exactly. So trailing zeros count if there's a decimal place. Well, there it is. So that means that this guy has got to count. So that number has 6 sig figs. Does everyone get that? Everyone good with that? We can move on?
Yes.
Okay. Are you sure? If there's anybody else, I'm
I have a
happy to.
question.
Yes. Go ahead.
I don't know if you were going to talk about this already, but is there any reason why they count if there's a decimal place present and why they don't count if there isn't?
So I was not going to go over that. That is just, it's again to show the amount of precision of of whatever instrument you're using, right? If I wrote instead this, right, that right there, well, that's not a good example because that's actually a 5. And those would be sandwiched in. But if I wrote 10,000, right, that's telling you that again, it goes to the place of where the last significant digit is. That's telling you that the only significant digit I have is in the 10,000ths place. If you have a decimal place right here for this number, why are you actually putting that 0 there if it's not significant? You know what I mean? If it's not a non-zero digit, if it's not a 1, a 2, a 3, why do you put the 0 there? If it's not significant, I guess is my way of thinking. But if that's not a good answer, I can get you a better answer. But that's what shows you. It's what shows you that those numbers are significant, and that's why you're putting that 0 there. Does that make sense or no?
That makes sense.
Okay. Whoever wrote the 5-4, can you erase that? Because I'm gonna scroll down and I might see it stays with us. So thank you. A good way so we're going to be dealing obviously with a lot of numbers, right? And I am very big on 2 things in my class. I'm very big with units, which we haven't gotten to yet, but I'm also very big with significant figures. So you really do have to understand how to do these, and you have to understand how to be able to work with these, because this is just, okay, I give you a number and there you go, tell me how many sig figs. But I'm never gonna ask you stuff like that. You're gonna be using these in calculations. So you have to be really comfortable with this stuff so you can actually do the calculations in the future. A good way to make it like there's no doubt, in the number that you're providing is to put the number as a scientific notation. Okay, so what I mean by that is if you look at this example here, they're all 1,600 feet. But if you write it like this, right? If you wrote it like this, if you wrote it like this, just 1,600, I would automatically think you're saying it's 2 sig figs because there's no decimal place. But let's say you didn't want, you wanted 3 sig figs, then I would just go ahead. So to remove all doubt, you can make the number into a scientific notation number, which would mean that yes, this is 2 sig figs, or no, this is 3 sig figs, or no, wait, this is 4 sig figs. So that's how it would look different. It's just something that it's a suggestion. If you wanted to remove all doubt when you're writing an answer, put it into scientific notation, because that's telling me for sure how many sig figs are in the number. The only thing you write in a scientific notation number are significant figures. So that is something that you could use. Do you have any questions? Do you understand that or no? All right, I'm moving on. So we've got some questions here. You guys are more than welcome to write if you can write or type neatly on the screen. But how many sig figs does the letter A have?
5.
It's got 5, and that 0 counts because why?
It's trapped between 2 non-zero digits.
Because it's sandwiched, right? You can say that because it's sandwiched in. All right, how about letter B?
4.
Okay. Are you guys taking that long to think about it, or just because it's
I was trying to let somebody else answer.
Oh, you're so sweet. Thank you for doing that. The people that are going to talk are going to talk. If you're not going to participate, you're going to see that's going to be a problem in this class. But thank you for doing that. So how about letter C, guys?
4.
4. Why is the 0 in the front not significant?
Because it's not after the decimal point.
It's a leading 0.
There you go. It's not because it's not after the decimal point. That's not the reason. Because if I put if I put this, right, 026, this 0 is after the decimal point, but that 0 is significant. So that's not the reason. The reason is because it's leading. It's the first one, and it's before any other non-zero. Does that make sense?
Yes.
Yes.
Right. So that would be 4, and the zeros after count because, again, the same reason, because you see the decimal place. What about letter D? That's easy.
5.
Yep. 5. 1, 2, 3, 4, 5. What about letter E?
5.
Okay. So you guys feel comfortable with this? You think you're good with this?
Yes.
Okay. So I want to go and talk about. Go ahead. Do you have a question? Sorry. Do you have a question? Okay. I don't know. I thought someone was talking. So okay. So I actually want to talk about rounding. And you're probably like, oh, I know how to round. Why are we spending time rounding? Yada, yada, yada. Yeah, but I bet you don't know how to round scientifically. So I am going to put the computer down and let's do some, if I gave you this number, yes, 7.0234. First of all, how many sig figs does that number have? Let's start with that.
5.
5, correct. If I asked you to round that number to the 4th sig fig, what would be the answer?
Do we have to write it or can we say it?
No, we can say it. We can say it.
7.023.
7.023. So basically, just so everyone understands, and I know everyone knows how to do this, you learned this in elementary school, but I asked you to do to the 4th sig fig. So now since you know how sig figs are counted, this is 1, this is the other one, this is the other one, and this is your 4th one. So I have to round it to this significant digit. Obviously what you did, so everyone can notice the process in your brain, is you looked to the next number. And if the next number was less than what, 5? Is that what you thought? It's less than 5, so therefore that number stays the same. Pretty easy, right? Okay, how about, oh Lord, hold on. How about this number? Let's do this again. 7.0 This is also easy. Round it to the same thing. Round it to 4 sig figs. Somebody else give me an answer.
7.024.
That's correct. It's 7.024. You did the exact same process in your brain. You looked at the 3, you looked at the number right next to it. It's a 6. That 6 is over 5. So therefore that number, that 3, has to go up 1 digit. Makes sense. Okay. How about this? 7.02351. I want you to round that to 4 sig figs. What is it?
7.024.
Yeah, the same thing.
Why 7.024?
Because we rounding it.
I'm sorry, say that again?
Because we rounding it to the 4th.
But why? Why? What was your reasoning behind that? You're correct. You're right. It is 7.024. You're absolutely right, both of you guys. But why?
The one keeps the 5 the same, and then the 5 makes the 3 go to a 4.
I don't think I understood that. Hold on. What?
Like if you working backwards.
Okay, so the number that we have that we're looking at, right, is the 3. That's the one that we're interested in. So what we do is we look to the next number, which is a 5, which is a problem because that's the middle. So then you look at the next number, which means that it's not half anymore. It is actually 51. So it's higher than half. So that is why the preceding number, the 3, goes up to a 4. Does that make sense? Which I know that's what you know. I know you understand it because you did it. But does that make sense to everybody else?
I have a question.
Yeah, go ahead.
So if we had the same amount of numbers, but the number wasn't 5, it was like 3, 1.
Okay,
like
hold on. Let me do it. Let's do it. 7.02331, right?
Yes.
And then I'm telling you, round it to the 4th significant digit. What number would that be?
With the logic you just gave me, it would still be 7.023. 7.024 because
No, it would
31
not.
is higher.
No, it would not. Absolutely
wouldn't?
not. No, it would not. Because again, the number that you look is, this is the number that you're concerned about, is this 3. So you look to the next number. That next number is not half. That next number is 3. So that means it stays at 7.023.
Okay, that makes a lot more sense then.
Yeah. Yeah, absolutely. So it's only when you have a 5. 5 is the problem, right? And then you're like, who cares about all this crap? Well, you might not care, but when people do oodles and oodles of data, like they're taking mounds and mounds of data, and you're trying to process all this data, this matters. Imagine if you just said, oh no, let's go up, let's round up, your data is going to be wrong. It's going to be skewed upwards, or it's going to be, for the same reason, skewed downwards. You can't do that. So you have to have an equal distribution of everything. So I'm going to give you one more example, and see what you guys come up with there. How about this number, 7.0245? Now, I want you to round to the 4th digit. What the hell do you do now? What would be the answer?
7.025.
7.025.
You
So
said
that's,
to the fourth.
that's what you're saying your answer is? Okay. Explain to me why.
You said to the fourth syndicate?
Yes, ma'am. Yes, ma'am. So to this number. Yes, ma'am.
Oh.
So what would be, if I want you to round it, are you keeping your answer? So if you
I'm keeping my answer.
Keeping your answer. So you said 7.025. Okay. Anybody else have anything else they want to say?
7.024.
Okay, here are the 2 different options. So why? Someone explain your reasoning.
Because you just said for the 5, before we did that, you would look to the next digit after the 5 to see if it's hot, if it's higher, right?
Right, if it's more than half, basically, right? But this is 5. This is just 5. This is 5. There's nothing after now. So what do you do now? Which, by the way, you are correct. You are correct.
I mean the 7.24. The 7.024. There it is.
Yeah, you're correct. So what happened? The rule is, here's the rule, so everyone can just relax. The rule is, if you've got, let's go back to this guy, the 5-1. Like you said, if you're looking to round to a certain number, but the number right next to it is a 5, and now you got to look to one number more. If it's a higher than 0, right? You got to move that digit that you're concerned about. You got to move it up. This guy, right? If you have a 7.25, but now you have nothing there, that means that it's not more than half. So it's sort of like you would consider it as less than, not more than half is not more than half. So therefore this number stays the same. So the true answer for that would be 7.024. Does that make sense to everybody?
Yes.
Okay, it should, because if this makes sense, then this one should make sense too. Okay, so yeah, go ahead. So
do we only look to the immediate next digit? What if it was 7.02450? We just ignore the 3.
That's a great question. That is a great freaking question. Because let me just write what you said, 724503. I want to say something that I said in the first class, but I don't want to confuse you guys. So for this class, and actually for science, I'm not just saying for this class, the rule is you look, let's say, let me change my color. You wanted to do to the 4th digit. That's the 4 is the 4th digit, significant digit. The rule is you look to the person next to that digit. Since this is a 5, you look and there is a 0 and a 3. So technically that is more than half, is it not? That is more than 5. It's 503. It's more than what, half would be. So you would think, well, then that should go up a digit. That should now be 7.025 as the answer. But the rule is to only look at the number right next to the 5. Since the 5 is next to a 0, or there's a 0 next to the 5, you leave it at 7.024. I will say that in this class, we're not going to have any situations. Like, I'm not going to provide a question for you in an exam that has this situation that you're like, oh man, what do I do here? You know what I mean? I'm not going to do that. And to be honest, most of the things that you do in this class are, what can I say, are super, super, uber small, right? We're dealing with atoms and particles. So you're not, in your calculator, when you calculate something, you're not, let's say, because if I tell you, you're not going to be able to see the end digit. And even like, for example, if it was instead 7.0245000000, like your calculator is not going to go that far, but then there's a 3. That technically is more than half, but you wouldn't even see that. So I don't even want you to think about that. I just want you to take the rule that I've given you and apply it as it's written, if that makes sense. So that means keeping exactly what we did. So this number up here would be this answer, 7.024. So to answer your question, Justin, is no, this would still, with our rules, this would still be 7.0245. Sorry, 7.024. My bad, like that. Did I answer your question, even though it might not be a good answer?
Yes.
Okay, awesome. So
I'm sorry,
now
I have a question.
Yeah, go ahead.
Okay, so is this only with 5? Like if it was 6, it would just be, you just round it up?
Yes, ma'am. This is, the 5 is the problem. That's the problem, is what the hell do we do with 5? When you're taking data, you've got to have a protocol. So to not skew your data upward or downward, you've got to have a system about how to handle 5s. So yes, it is only when you have a 5 next to the number that you're trying to round. Does that make sense?
Yes, ma'am. And I got one more question.
Yeah, go ahead.
Is this available to us? Like, can we find, like, I guess whatever you're like drawing on, like on Blackboard?
Can somebody answer that for her? Someone has to know. None of you know the answer to that question?
But
it's the same video from the Siegfried's quick tutorial, but
yeah, I know I watched it, but if I just wanted to like scroll in my like self and I had to stop the video or like do it like that every time.
Yeah, no, someone should know the answer to that, guys. Do you not know that we record everything?
So they're going to be on Blackboard.
Yeah, everything we do is recorded. Everything. So if you know that there's a Zoom folder, right, on your Blackboard course shell?
Yes, ma'am, I do.
Yeah, that's where they are.
I was just saying if it was like clear, I guess, with nothing written on it, because I watched the CHEM video, like the pre-video or whatever before this, and I was just wondering if we could get into like just this.
Yes, ma'am. So this, and it's exactly going to be our class. Like this, my screen is being recorded and our faces are being recorded. So our class is being recorded. So you'll be able to see everything that we've gone over with the writing and everything. Everything will be shown.
Okay.
Okay. Is that's what you were concerned about?
Yes, ma'am.
Okay. Yeah. So you'll just go to one second, Justin. So yeah, just go to on your Blackboard course shell, go to the course materials, or is it called? Yeah, course overview and materials tab, and then scroll down till you see Zoom folder, and then go to your section. Click on your section, and then all our classes will be there. Okay?
Yes, ma'am.
Okay, cool. So, yes, Justin.
I think if I understand her original question, she was asking, was it possible for you to share the actual notebook and then she can make her own annotations without the video?
Is that what you're asking?
Yes, he was on point with that.
Okay, well, you got to tell me. If I don't get what you're asking, you got to tell me. No. Okay, so you want access to my notebook? No, that's not going to work.
Okay.
Sorry. I mean, I could if you wanted to. They're just questions, but I could copy paste and
It's
email them to you. Or Justin, if you have an idea.
yeah. Since you already made the team for the section, you could just copy the page. Like when you go to the page view and it just has the single line with the name of the page, you could copy and paste that to the class notebook, and then you could distribute it to each student so they'll have their own blank slate of that page already in teams.
But I really don't want, and that's fine, I could do that. But I don't want you guys, just as a general, I don't want you guys to do the same problems that I do. You know, like I don't want you to memorize these certain problems. Like I want you to just try different things. But if you, and I think that was Jayla that asked it. Was it you, Jayla?
Yes, ma'am. I was just saying I just wanted like your notes on this. Not the problems, but just so I can rewrite the notes down or something like that. But it's okay. I'll just use the video.
I'm sorry. So I'm open to giving you everything that I use, as long as it doesn't give me oodles amounts of work. But I'm open to give you everything for sure. Anything you need that you think might help you, just let me know and I'll copy paste it and email it to you or whatever, or to the class or post it on Microsoft Teams or whatever. But as long as it's not like every week and it gives me more work to do. If that makes sense. Okay, so let's try some of these things on our own a little bit. These are easy. This is just rounding off to 3 sig figs. Let's do these quickly because I actually want to get to these guys down here on your own. 3.478, round them to 3 sig figs. Quick.
3.48.
Correct, and it's 3.48 meters because I have a unit there.
Yes,
Okay.
oh my goodness, I forgot about them.
Yes, so next one. Just 3 sig figs. Well, what would it be? That's easy.
5.33 grams.
Yes, sir. 5.33 grams. What about the next one?
4.81 centimeters.
5.81. 5. You meant 4.81. Did you say 5?
Yes.
Yeah. 4.81 centimeters. Everyone agree with that?
Yeah.
Awesome.
Yes.
Yeah, good job. What about the next one, D?
Would it go to 8.00 or like would you put 0 as placeholders to keep it?
You sound like you're confused. So go with your gut. Go with your gut. What does your gut tell you?
I think it would be 8.00 to
That's
keep
exactly
the
what it
3 inches.
That's exactly what it is. It's 8.00. Only 2 zeros, right?
Oh yeah.
Yeah.
Yes, ma'am.
So,
Sorry.
yeah, so 8.00 inches. That's exactly right. Because you've got to look at this sig fig, but then who's next to it? It's a 9. So that means this goes up. But wait, that means that this goes up. Wait, oh, yeah, it's 8. 8.00. All right. So, all right, let's do these on your own. Round 3.1416 to the hundredths place. What is that?
It's gonna be 3.14.
That would be 3.14. So everyone knows the hundredths place, right? The hundredths place is the actual 4. That's the hundredths place. So she rounded it to there. How many sig figs does her answer have? That would have 3 sig figs, right? Everyone? Yeah, cool. All right. So how about part B? Round that number to 5 sig figs.
1.2750.
Right. And see, that looks, it makes me so uneasy because I would want to say that that's 1.2751 because there's a 5 at the end. But according to the rule, we keep it at 0. So good job. All right. What about part C? 134.9. I want you to round it to the hundredths place now.
135.
135.00.
I'm sorry, 100.
Oh,
It'd be 134.90.
Wrong.
No, it's 100, right?
Guys, it's not hundredths, and hundreds is different.
Oh.
Okay. Reading is fundamental. So to the hundredths place, that's why the answer, I think it was already said, but the answer was 100, and that makes sense, right?
Mm-hmm.
Okay, how many sig figs would that number have?
It's 1, right?
It would have to be 1 because I'm telling you to round it to the hundreds place.
Mm-hmm.
Yeah. Actually, wait a minute. Pump your brakes, everyone. How many sig figs does it have currently?
1.
No, currently, like the number here.
4.
It
4.
has 4.
Oh,
It
the
has
4.
4. So I didn't say anything about changing the number of sig figs, right? I just said
Oh.
round it. I just said round it. So if you round it, you're right. It is 100. But what would be the correct way to actually write it?
100.0.
Ah, yes. I don't think I said that in the first section. Yes. So that's exactly right. I didn't say anything about changing sig figs. And reading is fundamental. All I said is round it. So if you round it, you can't start, you're not God. You don't change things because you want to change them. They started with 4, then it should have 4 at the end, right? Right. How about part D? Put that number to 2 sig figs. Round that number to 2 sig figs.
0.017.
Okay, remember the rounding rule? So we're looking at 0.0.
Oh,
Yep, okay.
0.0.
Okay, I'll just let you guys think. What do you want to say?
Would it be 0.02?
Okay, wait. Then you guys are getting confused. So 0.0165, right? First of all, how many sig figs does it have originally?
3.
Or
Right. So what does the thing ask you to do? Round it to 2 sig figs, yes? So the second sig fig is what number?
6.
That's right. So you have to round it to there. So go through the same process in your brain. Go to the guy next to the 6. That's a 5. Oh, crap. It's a 5. What the hell is the rule for the 5? Oh, is there anything next to the 5? Nope. There's nothing next to the 5. So what happens to the 6 then?
it stays the same.
That's exactly right. So the answer would be 0.016. Does that make sense?
Yes.
Yeah, so you got to go through your brain. Go through the steps so you don't get confused. What about part E? We're almost done. Hurry up. Come on. And read carefully. Yes, reading is fundamental. What am I asking here?
3 decimal places.
Right. So what would be the answer?
12.626.
Yay! Yes, because that is to the 3rd decimal place. So it would be this guy. Obviously, there's a 7 there, so you round up. Easy peasy. What about the last one? 106.5 to the nearest whole number.
106.
106. Okay. And does anyone disagree with her?
No, that's right.
All right, 106. And how would I write it? I just put 106.
106.0.
Ah, there you go. Now you guys are becoming professionals. Good job. Because I didn't say anything about changing sig figs. I just told you to round it. So very, very good, guys. I will say that Monday, well, we have 2 minutes. I know that I want you guys to, because I had time in the first class. I guess we took longer in this class, but we learned about sig figs. Now you can, like, if I show you a number, you can tell me how many there are. Great. You know how to round. Great. But now you've got to not just know that. You have to know how to deal with numbers when you calculate. Okay. That's what you're going to be doing in this class. You're going to be putting a bunch of calculations, a series of calculations together, and you're going to have to know what to do at the end with the sig figs. So the first thing is when you're doing a series of calculations, you don't round. You do not round in the middle. You only round at the end. Okay, so that's for rounding. But sig figs, you have to know how to take care of sig figs within calculations. So this isn't the other video that you have to watch soon, but there's only 2 rules. It's really easy. It's multiplication and division, and then there's the plus, addition, and subtraction. if I don't have time to go over it, but there is this quick tutorial that goes over that. What we're doing on Monday is not that. What we're doing on Monday is metric units, okay? So go to the metric unit quick tutorial, and watch it and study it and do everything else that you think is gonna help you read, because that's what we're gonna go over on Monday. And we are going to start the Microsoft Teams Pogo thingamabob, which might be a complete disaster, but we're gonna try. All right, so that's what we're doing on Monday. I'm gonna send you an announcement so everyone's on the same page. But look forward to this stuff, because this is what's gonna be really important. Understanding how many sig figs are in a number is dumb stuff. That's the beginning of the beginning. This is what you actually need to know is, okay, what the hell do I do when I've got to add, subtract, blah, 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 and then give a final answer. So you gotta make sure you know how to do that. So basically sig figs within calculations. All right, does anybody have any questions? Any questions at all? No? Okay, let me stop sharing. And I do thank you guys for being here. I will see you on Monday. All right? Bye, you guys. Thank you.
Bye.
Bye-bye.
Thank you.
Bye. Thank you.
Bye. You're welcome.